Today we're gonna have two sessions, two topics. The first part I'll be presenting, it's WinCC Open Architecture at a glance. And the second part is gonna be presented by my colleague, Kamal, and it's about the standardization. So WinCC Open Architecture. It is a part of our SCADA portfolio. If you joined our WinCC positioning webinar which we held in 2 weeks ago, you might remember this slide. Our SCADA portfolio consists of several products like WinCC Professional, WinCC version 7, WinCC Open Architecture, and we have WinCC Unified, which is not yet shown in this slide set. And we have seen the features and available options in WinCC positioning webinar for WinCC Professional and WinCC version 7. Therefore, we will not be covering them in this session, but we will be focusing on more to the WinCC Open Architecture functionalities. The WinCC Open Architecture is a platform that we can address the customer requirements, such as the customer-specific adaptations, whenever the customer needs any adaptation specific to their requirement, or being a platform neutral, or distributed systems, or widely distributed systems, and so on, besides the standard SCADA offerings. WinCC Open Architecture, formerly known as PVSS2, is a part of SIMATIC SCADA product family, and it's being developed within SIEMENS for more than 10 years now. And now it's perfectly integrated with the SIMATIC family, with PLCs and so on. WinCC OA can handle more than 10 million data points. It can support 2,048 distributed systems. I'm not talking about the number of devices, but number of distributed systems. And WinCC OA can run more than 30 kilometer geographically distributed hot standby redundancy. And with its openness, it can be a platform for customer-specific developments. That's why we call it the SCADA system without limits, even though there are limits, but these are like almost no limits. So what are the benefits of the WinCC OA system? First of all, it's efficient. You can install software in less than 10 minutes. With WinCC OA, you can do online configuration. The changes you do is immediately effective in runtime. You don't need to download or compile or nothing. You can do mass configuration, which is very helpful to shorten the go live on production or the changes you have done for your projects. It's scalable. You can work on single user configuration, and whenever needed, you can scale up to complex multi-server systems. It's innovative, allows value measurements down to 1 millisecond. WinCC OA is event-triggered system that allow fast reactions and setting activities on alarms and immediately effective. And it's open, it's object-oriented, platform-independent system. It allows reusability of the objects with the libraries. Today, WinCC Open Architecture is a perfect solution for large-scale systems, complex and customer-specific projects. It is also a basic package for OEM products and solutions. That means you can use it to develop a solution, as well as you can develop your own product while using the WinCC OA platform. And tomorrow, it's targeting to go for better integration of IoT requirements, better support of engineering with wizards or frameworks, higher focus on security certifications and more flexibility to design a state-of-art user interfaces. So what are the key features that makes this system so special and powerful? Let's take a deeper look. WinCC OA gives you the possibility to do the online object-oriented engineering, and with its data model, type instance concept, with the control manager, with API managers which are supporting the object-oriented programming languages. You can do online engineering, as mentioned. No compile or download is needed to make it active in your system. You can also do the multi-user engineering and mass engineering. WinCC Open Architecture is an event-driven system. This helps to reduce the communication load because only value changes cause an activity in the system. It has modular manager architecture. The manager, when we say managers, these are the autonomous functional units, and each manager uses its own process, and when you need to expand the functionality in the project, you simply add a new manager. While we're here, let's take a quick look to the managers of the system. We have event manager here. It is like the heart of the system and communicates with the different managers in the system. So we have also database and archive managers for data management. We have driver managers for communicating with the field devices. We have control manager, an API manager for processing and control functions. We have UIs for engineering of the graphical interface or database, or for runtime. We have redo to deal with the hot standby redundancy. And also we have the disk for the distributed systems. So while you can host all of the managers in the single machine, but you can also distribute them to the multiple machine to have a better performances, for example. As you've seen here, the event manager and database manager are hosted in server. These two has to be hosted in the server machine, but you can distribute the other managers to the other machines, as you see here, to have a better performance. Going back to the key functionalities, the openness here, by means of the supported standards or supported protocols, it's giving the flexibility to integrate the other systems. In example, with API managers or DLL extensions. With WinCC OA, you can have mixture of operating system in one project. That means you can have Windows, Linux, Android, iOS, and virtualization also possible. These are supported by WinCC OA. That's why we call WinCC OA as a platform-independent system. Online software delivery and remote installation is also possible to give you the more flexibility, and you can have widely distributed system with up to 2048 geographically distributed system. Some special functions, the structured hierarchy up to centralized control center. We have redundancy here. We have disaster recovery system, web server functionality, SSL and TLS encryption, SSL encryption, even the manager base, the user interfaces in desktop or mobile, remote client with ultralight client here, advanced multi-touch functionality, and enhanced trending. Some of the functions you probably are aware from the different SCADA systems as well. Maybe here we can open a special bracket for disaster recovery. This is a 2x2 redundancy. You have two redundant systems in two different geographical locations to control the same system. And in case of failure in one of the locations, this is meant for especially for the disaster scenarios that make system unavailable, such as earthquake or fire, or maybe it's just simply for maintenance purpose. One of the redundant stations may be unavailable for some time, and in this case, the other redundant system in different location will continue operation without any interruption. Besides that, there are some add-ons of WinCC OA in case you need additional functionality. For example, like recipes for managing the parameter sets and the set point list, or scheduler for settings for timers of timers and the events. Reporting to have an active connection to the reporting tools. Mostly here we're talking about the third-party reporting tools. Smart SCADA, as for the statistical analysis and KPI calculations, offering interface to system R. And we have advanced maintenance suite for managing the equipment failures and planning the maintenance work in an efficient way. We have map integration to have full integration of maps in the WinCC OA platform. We use either GIS Weaver or Maps Evo to have this functionality. We have integrated video management based on WIF 2.0 standard. It's the open network video interface form, if I'm not mistaken. And archiving based on a relational database or the history database or the next generation archiver is possible. And whenever needed, Oracle RDB database connection for long-term data storage in Oracle databases are also available. So we were talking about the openness of the WinCC OA, and here are some examples, some sample protocols that helps WinCC OA to be an open system. So it needs to manage interaction with the other systems, and it's only possible with its extensive list of supported drivers. Like here you see the MP3, Modbus, IEC 61850, 61400, or 60870. And S7 Plus, of course, drivers are available for SIEMENS systems. CNOT is there, TIA importer, cloud connector. If you're not able to find a proper driver that you're looking for your application, and there is always a chance to develop it in the WinCC OA platform too. And besides, WinCC OA fully meets the functional requirements of the FDA. So you can use these systems for food and beverage or pharmaceutical industry as well. Furthermore, here is the here is the list of the certified standards. WinCC Open Architecture is SIL 3 certified according to IEC 61508. And it is also certified by OPC Foundation, BACnet, Profinet, and IEC for the security-related standard. So now let's have a look some of the reference projects in WinCC OA in different industries. Let's start with the metro and railway. We see here maybe one of the biggest applications developed with WinCC Open Architecture. It's the passenger information system with more than 10 million data points in New York. There are metro applications in Vienna, Istanbul, Izmir, Munich, several locations in the world. From the oil and gas industry, we see applications like gas supply network here or the terminal automation system, oil field drilling solution, fuel stations, management system, and so on. So there are lots of applications available for oil and gas industry too. Coming to the tunnels and highway and road management again, we see a lot of important applications from across the world, like Gotthard-based tunnel in China. It's the longest railway tunnel in worldwide, and it's a reference project of WinCC Open Architecture. Eurasia Tunnel in Turkey. And there are also traffic management and coordination centers in several locations, like in Vienna or St. Petersburg, and so on. So I will not go in detail, but maybe after the session you may have a look to the reference projects in different industries like energy and district heating. We have several examples here. Water and wastewater, we have airports, we have water traffic projects, several references from renewable energy, some references for some research and development applications. Maybe here a highlight to the particle accelerator at CERN. Again, it is done by WinCC Open Architecture platform, and some more in building automation areas. So after the session, you can have a look in more detail, and please let me know if you would like to have more information in some of these reference projects. So I'll be trying to help you. So lastly, I would like to show you also the OEM-based solution based on WinCC Open Architecture. Maybe it could be an inspiration for you. This is the list of the OEM products in SIEMENS and products and solutions in SIEMENS which are based on WinCC OA. Some of them you may have already know or heard or maybe even used. Like here we have the Sigo CC or Cinema Server. There are C-Traffic products. These products are being used in different SIEMENS divisions or operating companies and being used as a product, but developed based on WinCC Open Architecture. And here are the ones developed by our partners, WinCC OA partners, and now they are selling those products as an OEM solutions from their side. Before I finish my session, I would like to also show you why WinCC OA is a perfect choice for partner solutions, because it gives you the basis for the standard SCADA functionality and standard SCADA drivers, but also gives you the possibility to develop your additional functionalities or any customer-specific customized libraries and interfaces. At the end, you can give a holistic solution to your end customer, which is maybe above what he wants and needs, and you can then guarantee the highest customer satisfaction. So that's the end of my presentation. Before I hand over to my colleague Kamal, I would like to mention one more thing here. Precast Maybe some of you know the company, already heard, or maybe already work with them. Precast is our official WinCC OA partner and the value-added reseller in Middle East. So if you have an inquiry related to WinCC Open Architecture, you can contact me, or you can directly contact with the Precast too. They will be supporting you with the pre-sale activities or technical compliance, product selection, and so on. So I wanted to give this information as well. Thank you very much for your attention. Now I will be checking the questions if there are any. Let me see. Okay, there was one problem with the slide. I hope it's resolved. Yeah, okay. No question yet. You can, if you have any question, you can ask now, or you can always contact me after the session also. Or with the feedback form, you can ask your questions and I'll be replying via email. If there is no question, I would like to hand over to my colleague Kamal. Even meanwhile, if there is something, I can reply on that. Yeah, okay. Yeah, okay, it's very good. There is one website, WinCC OA portal. I will be giving the link in this meeting chat. You need to register to that website, and there you can download the software WinCC OA. You can have a look. The trial license will be available with the download of the software, and trial license means that you need to restart the application in every 30 minutes. Actually, you can work in 30 minutes without any interruption. And then once you complete the 30-minute cycle, you just need to restart the application. That's all you need to do for the trial version. So I'll be giving the link here in the meeting chat, so you can have a look and give a try. Okay. If there is no other question, then I will hand over to you, Kamal. Thanks again for your attention.
Thank you, Wincc. Good morning, everyone.
Kamal, your voice is a little bit low.
Okay. Is it okay now?
It is better.
Okay, just hold on. Now it is clear, Wincc. Oh.
Tell more stuff. Yeah,
Okay,
it's better.
fine.
Now it's better. Yeah. It's
okay.
Perfect right now.
Thank you. Thank you. So once again, thank you all very much for your time, for joining us in our webinar sessions. I'll continue with the second session for today, and in different from previous webinars that we have been conducting last couple of weeks. So today in my session, we are not going to specifically look at one product, but rather I'm trying to explain a concept which will really help you, in developing your projects and getting your time to market reduced much, and as well as you could really achieve some efficiency in terms of your project development and your savings. So that is standardization. So first, we need to have a look at the term standardization itself. So what does standardization mean, really? We could go for a formal definition for this from multiple sources, but rather I would put it in a nutshell in this way. It really means the harmonization of various aspects of your project, may it be in terms of your procurement, may it be in terms of the programming what you're doing, or may it be in terms of the communication architecture what you're doing. So it could be really having a harmonized way of doing things, which really help you to reuse the effort that you have taken once, and also to have a very transparent interaction with different systems that you might end up seeing in the market. So in business administration, really standardization could mean standardization of products, or adhering to a certain set of binding rules, which will help you to streamline your production process. But by doing this, what we finally mean to have is actually an improvement in the overall efficiency, I would say. With the help of standardization, we can reduce the process cost overall. So what advantage finally do we get with the implementation of standardization? The primary factor is we'll be able to reduce the cost to a much larger extent. Furthermore, we'll be able to improve efficiency in terms of the way we develop the project, and in terms of the way we interact with a different system. And finally, we'll be having a standard set of rules, which would eventually end up becoming, kind of a go-to document for any kind of similar application that you will be doing in future. Throughout this session, towards the end of the session, I'll be concentrating a little more on what standardization possibilities we have from the TIA portal portfolio, and as well as what standardization possibilities you have as a programmer of an automation system. But before diving into that, I would like to highlight, the possibility of standardization exists not just in your programming. It could even be there in terms of your, when you select your process. You can make a decision that, any kind of order that comes for one particular application, we'll be always be using this particular type of controller, or this particular HMI system, or a particular IO system. So with this, your ordering process, the time taken by the back-end engineering team who will be developing maybe your design diagrams, your control panel drawings, or the assembly team who will be helping you make the control panel. So even before automation, a PLC programmer comes into picture, there could be a lot of places where implementing standardization could really help people. So with this one slide, the key point what I would like to highlight, as I was saying, standardization in general doesn't really restrict itself to the way of programming and the way of implementation of your HMI templates and logic control blocks, but it could be in different aspects of your overall business process. Standardization, as we speak, will become the basis for implementing different further systems. We are going to look at digitalization possibilities. How digitalization could help you build your own systems in a much less time-consuming fashion. But for those things to happen, the very basics. The very basic implementation, what you will be doing, a groundwork that should be done from your side would be to implement some levels of standards and some levels of reusable design systems. So the same is applicable for parallelization of different work process. So just as an example, if I am a machine manufacturer and I have a concept from developed from a set of requirements what I have, and before this finally end up in a real machine and the completion of the commissioning, it has to go through different steps in between the engineering phase. So very first, the mechanical concept will be prepared, then the mechanics will be designed for that. So if I am preparing something kind of a robotic arm system or a CNC system, different levels of mechanical aspects would become a basis for me to continue my work in terms of preparing my electrical wiring, and that will in turn become my basis for creating my software and finally integrating it into a complete project. So each and every team will kind of have to wait for at least some level of input from the previous team to really continue with their work if we are doing it without any standards implemented in the system. Whereas with the implementation of a standard concept in your overall process, people, all the different teams will definitely be knowing. Any machine that from our company that will be made will already be having a certain levels of mechanical structure, certain levels of electrical standards what we'll be using, and certain standard programming blocks what will be used. So because of this, every team need not really wait for the inputs or wait for the completion of the task from the previous team. They can work parallelly. This brings in the advantage also to the fact that when we are about to start the commissioning, very important, the entire team need not wait for the machine to be physically available to really start their testing. We can make use of the concept of digital twin. We can start the virtual commissioning. All the logic process what you have already developed could be tested, so that finally when the machine is really ready, we can just transfer the tested set of control logic into the system, and your overall process, overall commissioning and the machine building process will be over much prior to the planned time. So this is how standardization could be giving you savings in terms of the cost aspect of it. So what are the challenges? How are things happening in the market currently, and how this could be solved? What do we as Siemens have in our portfolio to offer you for this? Very often when I'm interacting with different customers locally, even in our region, I see that many of the customers of Siemens will be let me take the example of a system integrator who builds some panel for some particular application. And it is quite often that they will have to build a panel for similar applications multiple times. And every time what the customer will end up doing, they will open a project that was prepared before, then start copying stuff from that into a new project, or maybe they will do a save as of that project and then go through a very lengthy manual process, adjusting, cleaning up the mess in the old one, readjusting it to match with the new one. So this is a manual intervention, a manual method of doing a very simple stuff which could be reusable, which could be helping you to develop your process completely in a different fashion. Now, how we could solve this? Instead of opening that old project, copying the HMI faceplates or copying the PLC function blocks from the old system, if there were some standard blocks and HMI screens developed, let's take the example of a pump control panel. So if I am making some kind of control panel, some kind of automation system for controlling some pumps, so definitely I assume that in the HMI screen what you develop and even in the logic what you write, there will be some representation of the motors, representation of the pumps. Some faceplates might be designed showing the alarms and showing the operation modes and other details of the system. So all these, if it was standardized and made it into some library objects, which could be saved within your engineering software, then reusing it in a new project becomes very easy. Even testing the system become less. Even the system test could be done with less effort because you're already using a block from your library which was already tested and saved and tested and versioned accordingly. So you need not run your test from the ground up because you wrote the entire logic from the scratch, or you designed the entire HMI screen from the scratch, because you're already reusing the stuff what were proven before in other projects. So this is the concept that could be done, but how? Inside the TIA portal platform, we have all these options. If you are looking at the possibilities of having a library which could be used for saving your PLC blocks, your the tags that you define, even the hardware structure that you create. Everything is possible in the TIA portal library function. What is available, already available with you. You could use, I mean, at least in the latest versions of TIA portal, we have some version control system inbuilt available with it. So versioning of your project, versioning of your different components of your project could also be done natively from within the TIA portal platform. I hope many of you might have heard the term TIA portal openness. So with this, what we really mean is the different actions or different events that happens within the TIA portal platform. I mean, when we open the TIA portal software, we create a new project, we add the systems, we compile the project. So all these actions, we could do it from an external, software interface as well. So we are providing some APIs which you could use to have your interaction with the TIA portal platform separately. Hopefully, towards the end of the session, I'll be showing you a small demo for you with this, and then we'll discuss this TIA portal openness and how that opens the path for digitalization for your project execution in detail over there. Similarly, even for the creation of your HMI visualization, so we have some tools called as SIVARC, SIMATIC Visualization Architect, which could be used for creating different HMI screens with the tag connections and all directly made from within the controller logic what you already have. So we have a couple of tools up in our sleeves which you could really make use of for implementing all the solutions what we are about to discuss. So in all these points or in all these aspects, one of the very basic requirement, I mean, especially speaking a little bit from the automation perspective or the PLC or HMI engineering perspective, the very basic requirement comes in implementation of some programming standards. So from within your company or from within the as an end user or as an OEM, you can decide, okay, any development that we'll be doing from our side will be going through the following standards, which will really help you. So I hope you might be aware that if we look at the possibility of programming a S7 1200 or an S7 1500 PLC from within TIA portal, we could really make use of multiple programming languages. We could do it in, of course, the ladder diagram or FBD or SCL, sometimes even STL or high graph. Different solutions are available. Depending on the kind of application that you are trying to build, depending on the kind of work that you are trying to achieve, you could really decide what kind of programming language you do. You select, and from within your team and from the team that goes for commissioning or the team that does the maintenance of the entire machine, is it really readable for them? So what standard or what nomenclature rules are you using for creation of different tags? So how are you versioning your libraries and how are you versioning your templates that you create? How open or how easily could you import the library that you have created from one project to a different project? So all these really makes a sense. So if you are about to implement some standards from within your firm, from within your company for doing what we are about to discuss, these are some points which I really think you should keep in mind when you create it. So let me give you, let me start with a simple example scenario, so which will give you the idea what we are trying to mention here. I'm assuming, so you have three machines, one a saw machine, a mill, and a drill, which will be having multiple components in it, and the programming or the engineering side of it will be containing the following components inside that. So you'll be having, may it be a saw, may it be a drill or a mill. In all these machines, I'm assuming I have a conveyor belt, I have an operator panel, and then individually on each machines, I have a saw unit, a milling unit, and a drill unit. So, things might be pretty clear for you even now. I mean, when you are looking only at one job, it might not be so clear, but when you have an overall picture of different jobs that you might be doing over the course of a year, for example, you might see there is a possibility of different modularization that exists from within the platform or from within the portfolio what you develop. Once you identify that, you could really make use of this feature, and you could develop the blocks and develop the logic in such a way that you will not have to redo the entire design over and over again. You could really modularize stuff, make it open in such a way. I mean, we'll have some interfaces for each of this block in such a way that it could be reused with any of these individual systems that we are trying to build. So that also becomes a pretty important factor, how you define your interface. Once we modularize stuff, the interface that you design should be designed in such a way that it is independent. I mean, as much as possible, it should be independent from a specific project that you're trying to have. To give you an example, let's take the example of a simple push button. So if I write a block to handle different actions that comes from a input switch, just as a push button like this, maybe for different machines, I would need different type of signals to be extracted from it. Some of them may need the direct signal, or some may look for an inverted signal. Some application may require the edges. Some application may demand that you implement some logic to take care of the debouncing switches that might be happening. So when you modularize this, and when you develop a logic for this, if you prepare an interface including multiple aspects, so not specifically limiting yourself to one application, but you implement it to take care of different applications, then you have more freedom while you finally integrate these kind of things together. So the overall concept here is you will be making things modular, you will be creating individual library blocks, and that library development itself is actually a continuous process, I would say. So once you have the set of requirements, what you have, your development will be taking all the modifications, adaptations, and the requirements into the implementation aspect. They will review whatever they have done and test it, and this will be released as a library for use by different systems. This process, I believe, will be done continuously by the development team, and once a stable release of the library is available, they could easily hand this over to the application team, who might be using it in their commissioning task. So they will copy this library into their application. They might have to do some application or some customer specific modifications in it. With that done, they will do the troubleshooting, testing of it, review, and finally, once that all the functional test is completed, they might have a discussion with the development team and incorporate all the different changes that has to be done, and this will again be released as a next version of the library. So this kind of process, once you do it, and later on, in a very later or in a very new project, once I am using the block from the same library, just let me tell you one aspect. Just think of the testing aspect. I mean, testing of that entire logic. You are pretty sure that you're using a well-proven block from your standard library, so you can just concentrate on the testing of the integration part. You need not worry about how the logic within the library block itself is working. Is it really okay, or should I go in and troubleshoot that? So this is very much reduced. I mean, and you could really make use of that time in implementing a different aspect of your project. So this is how the library development should go on. Now, we were discussing about the interface. So once we create a library, the library block will be having some interfaces. So if it is a FB or an FC, I'm saying what all inputs and outputs you will provide to your block. Or if it is a faceplate for a HMI that you're designing, then what all events and what all block interfaces will you provide there? So these interfaces, what you design, this also need to be standardized. Otherwise, when we have different systems coming from different OEMs, all of them essentially trying to do the same thing, but their interfaces look different. So just to show you that, I'm considering, again, 3 different machines doing similar task, but given from 3 different OEMs. All of them are trying to give me some data, which I'll be transferring to my MES system. So when I design an data structure, which I'll be taking in from within the MES platform, if you see the present scenario, how it is happening, all of them are giving data. Just look at one example. I mean, I'm taking something called as a count. So the first machine manufacturer gives me with the name count, second one gives me production count, third one gives me good count. Essentially what they're trying to implement or what they're trying to tell me is same thing, but if the interface is altogether looking in a much different fashion, then it makes me a lot of effort for me to implement everything or interface everything into my upstream system. Instead of doing this, if standardization was already implemented at the end user level, at least, or maybe at the OEM level, and you could really implement such standards even while designing your library blocks or your data structures, what you're creating, then you can already see, I mean, how this will, really ease your life. So, what advantages for does standardization give for a machine manufacturer or for a system integrator? This is, I think, pretty, visible. You already can reduce your development cost. You are increasing your efficiency. You can already build a lead with your competitiveness with some end users. So once you have already supplied a standard system to one end customer, you can you can easily make an argument with them stating that the development or the backend engineering work what we have already done could be reused in a way, so this will finally become useful for the end user as well. So really, so standardization helps the end customers as well. How? So it is actually quite simple. Even for end customers, for a machine manufacturer or for a system integrator, implementing some level of standardization will help them reuse the same blocks, reuse the same designs what they have done. So they are really achieving some efficiency, or they are really gaining some time in that. But how end customers are really achieving from this, it is mainly in terms of how they would really go and do the maintenance work. So once they are doing some maintenance, or if they are attending some errors, if different if different systems what they have in their facility are having same structure of the data or same communication protocol that are being used, or same type of HMI designs that are available, this eases the work for the even for the service engineer or the commissioning engineer who are available at site for them to do their task. Even the back end support team who define some kind of documentation, who create some kind of drawings, even for them, these standardization implementation could be turning really useful. So coming down, so from the overall discussion what we had, if you are trying to do the standardization for a new project or for a complete process from within your business perspective within your company, then how the procedure will be. I'm just trying to explain a typical scenario with a simple example. This will really be different for every customers based on what they are trying to implement. But let's have a look. So if I have different set of machines available in the field, for these machines to interact to each other, you should already be implementing some levels of standardization over there, maybe in terms of what communication protocol you use, or also in terms of what type of data structure that you would define to transfer between these systems. Once your field level components or one your individual production lines are in standard, then designing the upstream system where you would utilize a SCADA or you would utilize any visualization stuff to evaluate your KPIs, you evaluate your OEEs. So for them, things will be much, much simpler. So even you could have a standard template or a faceplate designed at the SCADA level, which could really make use of the standardization, what you already achieved at the field level. Not just for the SCADA level system, maybe you have a supervisory coordination level controller in between, or some line controller in between. These line controller also, if they are interacting with these field level machines, having the implementation done at the field level or at the very basic level of your system really helps anything that come up from that. If all these systems are already following certain standard, everything is in sync with the requirements, then once you want to exchange the data upstream with your MES or maybe eventually with your cloud platform, then in all these aspects, your engineering effort becomes much less. So the very basic idea what I want to give you here, standardization is not something to be done at any higher level systems. This is, I mean, more or less, I have felt this feeling coming from some customers whom I have interacted with sometimes in the past. But I would really say standardization is something which should be implemented, of course, on different aspects of your complete business process, but especially from the automation side, it should really start from the field level on as far as implementation is concerned. So to summarize all these points, so how will you draft a standard? What procedure will you follow? So ideally, you will be analyzing the entire situation. You will be creating different modules which you identify. So once you analyze, you can really identify which all components of your system could be modularized, and you will be making some levels of standard and some levels of implementation in it, which you could really reuse in a flexible manner. But it is always good to note that different projects and each and every projects and each and every customer requirements will be very much different. So there will be, or there could be, customer specific or project specific adjustment or adaptations that you might have to do as well. So standardization as the base for anything else, it will make your generation of your entire engineering stuff easy. Your test and simulation part will be easy. Once these basic or groundwork is already done, the digitalization that you are trying to do will be could be achieved in a very easy and powerful manner. I have compiled some links for you to have a look and for you to read through on the topic of standardization. But the presentation aspect of this, that's from my side, but I would like to give you a little bit of demo on these topics what we have been discussing. So please excuse me while I switch to a different machine. Okay, so I hope the screen is visible right now. I'm trying to simulate a couple of simple scenarios here. Very main or very basic stuff. When, as a company, when you get the requirement for any automation system, I believe one of the very basic tasks that you will be doing is to design a system and prepare a BOM for that. And if you're already utilizing different tools available from Siemens, then you might be knowing we have a tool called as TIA selection tool, which could really help you in doing this. I'm not here to tell you how TIA selection tool is to be used. I hope you already are aware of that. If not, please let us know in your feedback. Let us know in your comments. We could maybe think of arranging a session on this in some later stage. But I have done here, what I have done here is I prepared a sample project with 3 devices already selected. So I have added a PLC station here. Okay. I have added a PLC station, one S7 1500 series PLC is added. 2 remote IO racks I have added. So one rack with maybe around 5 modules and one more rack with around 10 modules. Just the imaginary situation, so to speak. All these are taken, and you might be knowing you could really use this to generate your BOM. But I'm not sure how many of you are aware that you could actually also design your networks and design your interconnections from within the TIA selection tool itself, if it makes sense to you. So that's why we have a network view, something available here. Just like the network view, what you might see in your TIA portal, we have something in the TIA selection tool as well. So you can really drag and drop and connect them, and you can assign the remote IO to one of the PLCs, or you could really assign them to the PLC and mention that all these 2 remote IOs are really connected together and interface together. So anyway, this is how you use the AI selection tool. So someone from within your team, especially the estimation team or the design engineer, will be spending some time designing this, selecting this, and they'll be generating a POM with this. Later on, when the PLC programmer comes from within into the TIA portal, so I have just opened a sample project here. This is an empty project. As you can see, there is no device added into it. So he will have to start adding the devices into this and make use of the entire TIA portal platform to create the project from the scratch. Now, if we are telling you so much, you could really reuse the engineering work that you have already done, then we would definitely be giving you some provision for that as well. And yes, even within TIA selection tool, we have some options that you can import, export different configuration into multiple platforms. For example, this present configuration where I have made a group called as control panel. Within that, I have added 3 devices, a main PLC and 2 remote IO racks. This entire configuration, I can export it just by going into project, export, and I can export it to be reused in SIMATIC Manager platform, or I could reuse it in a TIA portal or ECAD. I mean, those of you who use ePlan systems and all the latest versions of ePlan would really get the details from the TIA selection tool file that we are about to import. So I want to reuse it in TIA portal just to give you a demo. So I'm using the TIA portal functionality here. It gives me option whether I am exporting it to version 16 or with version. I'm going to use it in version 16 and just say export. I need to show a path. So let me save it in desktop, webinar, demo TSP selection folder. I will just use a path to save it. Right. So here, as you can see, there is a file called as demo selection.aml. So it is something kind of an XML file, but more specifically meant for automation world. So an AML file is generated. Just remember, this file is right now generated from TIA selection tool. Now, when I come to the TIA portal platform, as I was saying, all I have is an empty project, but no devices or nothing available in between. What I could do is I could import the AML file what I exported from that. So I go to tools. I have import data option available. I can go to the corresponding folder, webinar, demo, and this is the AML file which I have created before from the TIA selection tool. I will open it. I hope you know what's about to happen. Please give it a moment till it compiles everything and exports here. Also imports here. So if you could have a look, you have that same control group here with the control panel, the PLC what you have added, the remote IO stations. I mean, to show this, let me go to the network view. So what you could really see, it is not just the control, not just the PLC or the IO station, even the network architecture what you have created from within the TI solution tool, you are getting it here directly. If you want to have a look at the device, your main PLC contains the same controller what you have designed before. Or if you go to the remote IO 1, the same IO rack with around 5 IO modules, and remote IO 2, where I have included just randomly 10 IO modules. Everything is visible here. I'm not bragging this demo much, but let me also tell you this. I mean, maybe this was given to the automation engineer. He is already utilizing this to continue his task of programming all the configuration. As you can see, is already done. But while doing the configuration or at a later stage during the programming, maybe he realizes that he wanted to add some additional cards here. So maybe just to show you, in remote IO rack 1, I'm going to add 2 maybe 1 or 2 Modbus communication cards. So I add the card here, 1, 2. So 2 more cards are added. Now, if the PLC programmer want to give this information back to the designer, so that later on when he do the TI selection tool design for a later project with a similar architecture, what the programmer can do is, instead of telling him, okay, add 2 communication modules, instead of saying that, he can really do the reverse task. He can export the data from here as an AML file, and he can transfer the AML file to the designer, who can import it back in the TIA solution. So the work or the time that you are spending in doing some kind of work need not be gone waste. You can really make use of it to reuse the stuff what you have already designed and tested. This is what I'm trying to say. So this is one demo what I wanted to give you. So some of the tools that are already available with you, which you might be already using, but you are not aware of how you could really make use of this. That's what I wanted to show here. Now, to give you a simple demo of the openness feature, what I had discussed before, let me also take you to this one. I have created another sample project in DIA portal. I mean, now I'm using version 15.1 just because the demo version what I have is with that. So here I have created a PLC. What I have done is I have made a project, openness demo project. I have included one S7-1200 PLC with some logic and with some configuration available in it, and the name is PLC. If I ask you to generate or develop a project like this, you know how to do. You will open TIA portal, you will open the new project, you will add new station, and you do everything as you normally do. But let me tell you another hypothetical scenario. As I was telling you before, you are a pump, okay, at least this example, assuming you are a pump control panel designer, this is one of the regular tasks that you do. So once you get an order, so you know, this panel is going to be for controlling maybe 5 pumps or maybe 3 pumps. To know that. Once you know that, you know if it is for 3 pumps, what I need is these hardwares, and my blocks will be copied these 3 times. If it is for 10 set of pumps, I know, okay, IO modules will be more, the blocks will have to be copied multiple times. But right now, you are doing all these things manually. But as I was saying, right from TIA portal version 14 onwards, we have some APIs that we give you openly, some DLL files, to be more exact, which you could really make use of it in your in a program that you could develop. So I'm just showing you one demo available. This demo what I'm showing you is from the support site. So we have an application example where this option is developed. Let me just open it. Okay. So this is just a demo application. Please don't think that the open has always been this. But the idea here is, as you might have seen from the folder what I opened, this is nothing but a C# program what is developed in it is a C# program developed in Visual Studio. But we provided, we are providing the DLL files, the open APIs, which you could utilize in developing something similar to this. Not necessarily this one, but something similar to this. So let me show you what all things could be done from the API what we provide. If you want, you can start and you can create a new TIA portal instance from within the openness interface what we have. Or if already one TIA portal instance is open, like what I have here, you could use your API to connect to it and do stuff on that. So for example, I have one project open here, and the name of the project is Openness Demo, as you might be seeing here. So what I'm going to do is I'm just going to connect to my OpenTIA portal. So it got connected. From within that, if you want to do different stuff, so just to show you, right now what I have here in my TIA portal, let me open this also here. Right now what I have here is one PLC, which is an S7-1200 PLC of the name _PLC. But if you want to add a new device into your project, so if I click on this button where I have already typed in the part number as well as the version, firmware version, once I click the add device button, let's see, hopefully it doesn't crash on the live demo. Okay, so what you see here, you got one more device added and you are ready to go and configure this. Again, let me tell you, What I want you to know is the fact that it is not for just adding a new device. Don't think that okay, this I could do just by clicking the add new device function. No, if I can add new device just like this, please remember that I can also add devices into the rack, adding the IO cards. I could, if you have already developed and made some library files available, I could really make use of the library to automatically populate the new device what you added with some library blocks inside it, and just to test, you could even compile this stuff here. So this is actually a unsaved project where I just added a new device. I could compile it from within my openness portfolio. See, once I press the compile button here, you can see in the background the TIA portal is doing the compilation and it returned zero errors or warning. Not only the device what you add, if you want to compile the device what was already there, for example, I had the device called as pump PLC. If I prefer to compile that, see now pump PLC is getting added and I purposefully made some errors in it. So you could end up in this such situation and your API can even read that as well. So the idea here is whatever you are trying to do, you could do it in a much automated fashion, which means once you have, once you really go into the way of digitalization, which I'm pretty sure, sooner or later, everyone will reach there. I know this is not a very common topic in our region, at least as of now, but pretty sure this will be the way that the whole market will be moving. When people are thinking, people are talking about cloud platforms and people are talking about edge computing. So I don't think that the entire engineering team will still be doing the complete manual work as they were doing things before. So what I would really think of is, just again going back to this example, what we have been taking of a pump OEM. So when the company gets a new order within their company ERP system, once they add the number of or the specification of the details, using an API, using a program that developed something like this will be used to read the data from your database of your ERP system, read how many modules, how many controllers, which type of blocks and all will be required. So as a new project is entered in your company ERP, parallelly one TIA portal project with the necessary modules with all the library blocks will also be ready. So the programmer who is doing or the commissioning engineer who is doing will just have to do some interconnection here and there, connect it to some field IOs, physically what are being used, and then really use it. So you could really take it to that extent. But again and again, for doing all those things, the very basics of what you need is to implement some levels of standard. You wouldn't really prefer opening an old project using the API and copying blocks from that into a new DI portal instance, no. But rather you would prefer utilizing the global library function. Here I have just I have just opened a global library again, LG of library of general functions, which is again available from our support site for you to pre-download. I could have a list of blocks used for multiple functions just like this. And once a library is available, then you could really make use of these to be imported into your project and make your engineering work much more efficient. That's what I would prefer you to take away from this whole discussion. Okay, so quite frankly, that's it from my side.